Welcome. Today we will be taking a look at the notes worksheet entitled Quadratic Functions Day 2. And so just a natural extension of what we did yesterday, dealing with the quadratic functions. We're going to see a different form today, by the way, and kind of work through the algebra of that form. So let's start it out. Good example here, just get us going. A little contrived, but I kind of like it to sort of review what we looked at on the previous notes worksheet. So it says, what is the largest rectangular area that can be enclosed with 300 feet of fencing? What are the dimensions of the rectangle? So we've probably done a couple of these before. We're going to construct a quadratic function and then manipulate that quadratic function in order to answer the question. So we have a rectangular area, 300 feet of fencing, and we want to maximize the rectangular area. Okay, there it is. So largest rectangular area. So if you remember what we've seen before with this, X and Y basically would do the trick there, however you want to play that out. And I hope everybody is comfortable with the fact that the area of the rectangle is just that length times width. I called it X times Y. And as we have seen before, this is an equation, but unfortunately it kind of has two variables on this side over here, and that's not exactly what we want. We want to try to write a function for the area in terms of a single variable. And so as we have done before, circle the secondary variable if you would. Circle the problem. And so what we need is a second equation that will allow us to go ahead and replace that y value right there. And so you look at the problem, of course, and it's relatively straightforward in that there's just 300 feet of fencing representing the perimeter of this rectangle. So this plus this plus this plus this is all 300. And so I think this is a fairly natural equation coming from the information that 300 is equal to 2 x's and 2 y's. And remember what I've said before with this. This has always been my mantra. Basically, if I want to replace this y right here, then I have to solve for y in the other equation. So I'm going to go ahead and solve for y in this equation right here by subtracting 2x. Okay, just nice algebra right there. And then how about dividing by 2? And that 2 goes in evenly on both terms there. So how about a 150 minus x? All right, there it is. Okay, so if that is equal to y, then it can substitute in for the y. And watch what happens here. Again, probably have seen something similar to this before. But basically, now I have the area in terms of just one of the dimensions. That's pretty powerful mathematically. As x changes, the area is going to change. What do you say we clean this up a little bit? If it's okay with you, I'm going to now go ahead and think of it as a function, area in terms of x, so a of x, and distribute that x in. I would get the 150x and the minus x squared. And again, if it's okay with you, I'm just going to change the order on that, kind of get it looking in that standard form. And that's looking pretty good right there. I don't want to necessarily box it up, but I think that's a good stopping point for just a moment. Obviously, we haven't answered the question, but we have at least created the function. And notice that that function, area in terms of x, you have your ax squared plus bx plus c on the back. Standard form quadratic. And don't forget from yesterday, anytime it talks about maximizing a quadratic, with that a value being negative, you know you're talking vertex. And so I'm actually going to write that right here. We're looking for the vertex. So there are an infinite number of ways to construct this rectangle. An infinite number of x's will produce an infinite number of areas. There happens to be one optimal way to construct it to maximize the area right here. So how do we do it? Rather than graphing it, and actually I would encourage you to do it algebraically. I think it's quicker. By the time you try to find a window for this and get a maximum, I think you will have solved it, algebraically. So here's what I'm thinking. Vertex, opposite of b over 2 times a. Everyone okay with that? So negative 150 over 2 times negative 1. And so the x value here, of course, is going to be 75, and I'm going to throw a little feet on the back. So really, look, that was pretty quick, right? Didn't even need a calculator for it. And so I have now that the x value, this should be 75 feet in order to maximize it. Now, what would be the maximum area? What is the maximum space enclosed in this rectangle if that x is 75? So I'm going to bring my calculator up. I have some stuff in here from the previous lesson. Let's clear it out. And remember what we're looking for here. We're looking for a of 75. Actually, I should put that up first. So we're looking for the area when the input is 75. Remember a vertex, everybody. This just gives you the input, and then that goes back into the function. So let's be very clear on that. And when it does, what quantity does it give us? It gives us a. So I want the area at 75 feet for x. Good, I hope that's pretty clear. I've seen some students over the years sort of mishandle the interpretation here. So I have a -1 times 75 squared plus 150 times 75. I hit enter there, and it looks like I get 5625 square feet. That looks great. I'm going to go ahead and put that in right here. So 5625, I believe I saw, square feet. And that would be this right in here. I'm going to go ahead and just sort of do a redundancy on this. But that's not y. Just be careful. That's what I've seen over the years. They'll think, oh, I'm always taught that that's the y value. No, no, no. Always be careful on your quantities. It's area in terms of x. X is the input. Area is the output. And that's what we get right here. So I don't actually have y just yet. Okay, but I do have the maximum area. It says what is the largest rectangular area enclosed. I have it. The only thing I need is the other dimension. So a variety of ways to look at this, guys. I've got a lot on my board here. You have a lot on your paper now. Do you see a way to get the y value? I see two ways. Number one is right here. I know y is just 150 minus x. X is 75. 150 minus 75 is 75. So that is going to be one way to pull it off. There's 75 feet. Another way, of course, is if this is the area and this is the length, can I just take this and divide by that, and that would give me the width? Yeah, sure. So again, you go with what works for you, what you see. But ultimately, you see it's a perfect square that maximizes the area in. So even though there are so many different ways to make this rectangle, the square is the best way to go. Now that is for this one. So we're going to do some other ones that are a little harder, and that will not be the case. So please get comfortable with the math here and don't try to shortcut it. In this case, when there are no restrictions and it's just 4 sides, yeah, square is going to do it. But we're going to see some harder ones in the near future, so be ready. Okay, good starting point. Let's go forward. Now it's time to get into the second form of a quadratic function, sometimes called the vertex form. You'll see it called with me the completed square form. So everyone, if you would, let's go ahead and box up a couple things here as we start this out. Let's box that up. There's your standard form right there. And then what we're going to see now is this new form emerge right here, what's called the completed square form. And so let's do just a couple things first, just get us thinking about it. I put 3 quadratic functions in both forms on your paper. So let me just be clear about one thing. This right here is the standard form of a quadratic function, forms a parabola on the coordinate plane. This one over here is the completed square form of the exact same parabola. All the x's and y's that make this true also make this true. Same parabola from 2 different forms. So let's do this piece right over here, guys. You'll see in this new form we have a, and by the way, a is the same in both. There's a there, there's a there. So a is the same. You have your x's and y's, but we have this h and k form. And you'll see h and k come up quite a bit in the near future. For right now, you'll see it just in terms of this form of the quadratic function. So x minus h squared plus the k. So let's go ahead and get h and k for each of these, and then connect it to what's on the left side of your paper. So here's what I'm thinking. H for this. And just be careful, it's x minus h. So when I see an x plus 3, really that is x minus negative 3. So I hope everyone's cool with the fact that that is negative 3. And then a minus 1, it seems kind of silly for me to do it this way, but it's the same as saying plus negative 1, right? So plus k, so k is negative 1. So just kind of be careful about that. H is usually, well, it is the opposite of what's here, and then k is what's out there. You are going to have to kind of remember that piece. So h is negative 3, and k is negative 1. All right, next one. H seems to be 2, because it's x minus 2. So h is 2, and k is negative 18. Last one, looks like h is negative 2, because again, this really is x minus negative 2, and k is positive 4. Now, if this was kind of a standard traditional class, I would probably break these up and have you guys come over to the left side at this stage and actually calculate the vertex for each of these three. I'd probably break it up, and we would kind of see the conclusion to be had here. Obviously, I can't do that, so I'm going to do one. I would ask you to pause and do another one, and then we can just kind of fill in the table from there. So here's what I'm thinking. I'll just work off to the side. If I asked you to do a little quick opposite of b over 2a for this one right here, you would all do opposite of 6 over 2 times 1. And so opposite of 6, negative 6 over 2, it looks like it's negative 3. So I go ahead and I put negative 3 right there. That is the x value of the vertex. The y value, of course, would be for me to go ahead and put in actually, let me change this up, sorry. Let's do f of negative 3. Let's do that function notation. I like that better. So the y value of the vertex, of course, is f of negative 3. So 6 and negative 3, and add the 8. And in this case, it looks like I get a 9 minus 18. So that's negative 9 plus 8. Negative 9 plus 8, everybody, is negative 1. And that would be the vertex for this particular equation in standard form. Notice, look over here, everybody. Look at h and k. Coincidence? Probably not. Well, I would encourage you to pause the video and find the vertex for this one right here. Do opposite of b over 2a, and then plug it back in. If you did, you would see that opposite of b over 2a gives you positive 2. It looks like you get 8 over 4. You plug it back in, and I believe you get negative 18. Awesome. I would do it a third time, just to verify. Opposite of b over 2a. It looks like I would get 12 over negative 6. 12 over negative 6 is negative 2. I put that back into the function, and guess what you get? 4. So in this form, the nice thing about working in this form, as you can see, is that vertex is embedded in there. The vertex is h and k. How cool is that? So in standard form, we have to calculate that vertex doing this piece right here. Everyone see it? In completed square form, that is your vertex. Cool. Let's put it in, do some of the algebra that goes with this. So in completed square form, and you'll see why it's called completed square form sometimes. Sometimes it is called vertex form, obviously now. You can see why. So in completed square form, the vertex is h and k. Superb. All right. So let's do some of the algebra that goes with this. Very typical problems. Now, I'm going to teach this particular way, kind of I would consider it a higher level way in terms of the algebra that's required to do it. If you come up with a different way, I will not discourage you. Again, you go with what works for you. But I know that completing the square is just a skill set that comes up a lot at this level and the next. And so I'm going to focus my attention on the technique of completing the square. So again, if you come up with another way, it's fine. But I really like the technique of completing the square, and I'm going to use it. So example 2 kind of has an easy and a medium and a hard. So let's see if we can go through it together. So example 2, Convert each quadratic function to completed square form, then determine the vertex. All right, so let's see what we have going on here. There's your standard form, and I'm going to go ahead and convert this on over. I'm going to rewrite this just so I have a little room to work, and I'll show you what I'm looking for. So we are going to, as the name suggested, complete the square to change the form. And remember how we always complete the square. From the first two terms, and we always want just a single x squared out in front, which I have. That's what makes this the easiest of the three. So let's do this. Give me an x squared minus 6x and put a blank on the back. Now the 11, I'm not going to move to the other side. And we'll talk about that piece in just a moment. Just push the 11 towards the back there, and then I'll sort of go through what usually happens in this case. So first and foremost, you should all know how to complete a square. I take negative 6 and divide by 2. I get negative 3, and negative 3 squared is positive 9. So I would put a plus 9 right there. Now what would be your natural instinct in an equation? If you add 9 here, you would of course want to add 9 on the other side, right, to keep it balanced. And I agree 100%. Here's the problem though. This is not an equation in one variable. It is a function in two variables. And our function has always been in y equals. I don't want to mess with that. I don't want to put another 9 over here. So the question is, do I have an alternative approach? Rather than adding 9 to the other side and messing with this y right here, is there another thing that I can do to keep it balanced? And the answer is yes. So instead of adding 9 to the other side, I can almost sort of treat it in my mind to bring that 9 over and put it on the back as a minus 9. I hope everyone's okay with that. So adding 9 and subtracting 9 on the same side does not affect it. I haven't changed anything. So some students over the years I've seen literally put a plus 9 on this side and then a minus 9 underneath and a minus 9 over here and then do it that way. Fine. But you don't want to mess with this side because it's a y equals. Okay, now let's go for it. The whole reason for completing the square, of course, is because of the way it factors. So you would factor this, and you would get x minus 3 times x minus 3, which is, of course, that right there. Then, here's the beauty of it. You would combine those two together. 11 minus 9 is a positive 2. And if you look at the top of your page there, or wherever it is, does this look like completed square form? Sure. A x minus h squared plus k. And so the vertex, everybody, is h and k. I'm seeing this as a positive 3 and a positive 2. Wonderful. All right. Now here's the medium level problem. And we'll see why that is momentarily. I'm going to rewrite it, and we'll get going. So we always complete the square from the first two terms. And we always want a single x squared out in front. Unfortunately, I've got 2 of them. And so there is a way to remedy this that's a little different than what we've seen before. I don't want to divide everything by 2 because then I would have to divide the y value by 2. And I don't want that. I don't want to mess with the other side. So here's how it works, everybody. This is really good math right here. Circle those 2 pieces. I don't need to worry about the 5. The 5 is a little entity unto itself. It can stay on the back. But what I can do is start getting this in the form just like this. Let me go back to the screen. And do you see that a value? The a value is 2. Well, I'm going to pull it out. And so what happens is I'm just going to pull out the a value in front of the parentheses. So you see that there is a 2 that can be factored out of those 2. That's what I'm going to do. I'm going to factor a out. And when I do that, it becomes x squared, and it becomes a plus 4x. And now I'm ready. That's the key. 2 terms, single x squared. It's ready to be completed. Now the plus 5, again, kind of sits on the back, and now I do it intuitively. I just put a blank on the back because I know I have to balance the equation. Okay, that's what it's going to look like right there. I hope that step makes sense. Now everybody, what goes in the blank? X squared plus 4x plus 4. Now here is the key. You put a plus 4 right here. And it would be so tempting to put a minus 4 right here and think you've got it. Unfortunately, that wouldn't be the case. So what does go here? If you look at this in detail, I didn't really add 4 to the right-hand side. I added 2 times 4. Because remember, here's the 2x squared. Here's the 8x. So in reality, I added 8. 2 times 4 is 8. So I have to compensate for a positive 8 with a minus 8 on the back. That's huge. Now it's ready. Notice, look at that. There's your a. I told you it stays the same in both forms. In this case, it just sits out in front. X plus 2 squared, 5 minus 8, everybody, negative 3. Vertex, how does a negative 2 and a negative 3 sound? Great. Really, really good one. So factor out of those two. We'll repeat it one more time. Okay, so I said it kind of goes easy, medium, hard. This isn't dramatically hard. It just has one more added layer to it. So again, I'm going to go ahead and just recopy, just giving myself a little more room to work. And what I do right away, just for me, as soon as I see that number out in front, I go ahead and circle those two. I do want to complete the square from those two terms. The plus 4, forget about for a moment. And the form works by taking a out of those two terms. So it's a negative 2 that comes out. Now just be careful, it's just good math at this point. If I take negative 2 out of this, I get x squared. If I take negative 2 out of here, I really get a minus 6x. That's the key, because negative 2 times negative 6 is the 12. Now it's ready. Put the blank on the back. Here's the plus 4, and I have to keep everything balanced. So again, rather than putting it over here, I just undo it over here. Okay. If you could fill these two blanks, you've got it. And you can work through just about any problem that I give you. All right, well, here's what I see. A plus 9 definitely goes right in there. No question about that. Now here's the thing. It's not just as simple as a minus 9 here. What I really added to this side, because here's your negative 2x squared, here's your plus 12x. What I really added, everyone, is a negative 18, negative 2 and 9. And so if I added a negative 18, then I have to add a positive 18 right there on the back. And there we have it. Negative 2, factor this, it's x minus 3 squared plus 22. Vertex, 322. I really like that, the math that goes behind that. Some good theory behind that, of course, and then good execution as well. All right, so you'll get some practice trying those problems. That's definitely very typical for this level. Another good algebraic one before getting into the application is 3. I would love for me to do A slowly, and then for you to pause and try B on your own, but we'll see how that goes. So here we go. Example 3, write an equation for the parabola under the following conditions. Vertex is this, and passes through this right here. Now, don't write anything on your paper, but we have two forms of a quadratic function to model a parabola. This and this. With this information, the question is which form would be better? I have a vertex at 2, 4, and it goes through 4, negative 8. Well, if it's the standard form, all I can think of is this is an x and a y. I could plug that in, but I'd still have a, b, and c. This is an x and a y. I could form another equation, but I'd still have a, b, and c. And then what would I do from there? Jeez, I have no idea. So I don't know that the standard form really works just for this information here. But if you look at it from this perspective, I have the vertex, right? Isn't that h and k? And I have a point on the parabola. Isn't that an x and a y? So I have h, k, x, and y. What's the only thing missing that I could then solve for? A. And that's what we need. We need this, we need that, and we need that. And so guys, I think that's our winner. We're going completed square form on that. So let me erase, and let's label a couple things. And this works great. Everyone, if you would, H and K. There's your vertex. Given the vertex, I think we're going to go that route. This is just an X and a Y. And now I solve for A. So everyone, get very comfortable with this piece right up here. Don't forget the squared. Actually, over the years, one of the only mistakes I've seen students make is forgetting a squared. So don't forget the squared. And that's it. I've got 4 pieces to the puzzle. I solved for the 5th. So the Y value I saw was -8. A is unknown. The X value is +4. The H value is 2, so I'm going to have a 4 minus 2. Don't forget the squared. And then +4. Now just be careful with your order of operations here. This is multiplication. Well, it's sort of exponent and multiplication and then addition. Exponent comes first, multiplication comes second, and addition would come third. So let's clean this up a little bit before we try to get ahead of ourselves. So I see this as 4 minus 2 squared. So that seems to be 4. So A times 4 plus 4. If you want to immediately change that to a 4A, you're more than welcome to. As a matter of fact, just for me, it's the first time going through this with you, so I will do that. And you're solving for A. So just be careful. I've seen students over the years like combine this together, but that doesn't make sense because multiplication comes first. And so you've got to attach those. But now I definitely go ahead and subtract 4 on both sides, and I get -12. And then I divide by 4. And there you go. There's your A. And so what that then allows us to do, let's come up here, let's write our function. Y in terms of X. And we want to write our function for the infinite number of points on the parabola. So the A value apparently is -3. And I have X minus H squared, so X minus 2 squared, and then plus K. And there is your winner. Take a look at that math. I'm just going to take a look visually just 1 sec here. Here's what's kind of interesting about this. Vertex is 2, 4, which is up here, give or take. This point on the parabola is 4, -8, so I don't know, that's somewhere down here. And for this to work, this has to be a parabola that looks like this, right? Because the vertex is, in this case, the maximum. So just kind of looking at that piece, what do you know had to be the case about our A value? Well, A is negative. It's a parabola opening down. Awesome. Okay. So I hope the math behind that one makes pretty good sense because I would love to see you pull this one off. So same exact thing, just reinforcement there. You have the vertex. That's your H and K. And you have a point that is a single X and Y used temporarily to find A. So there is a singular A that works for this function. Let's find it. And again, I'm just going to be visual with this. Maybe you're working on it. Maybe you've paused. Who knows? -3, -2. Yeah, it's about right there. -2, 4, right there. So your parabola is looking like that. And so I see the only way to make this work is to have a parabola opening up. And so A should be positive. All right, I'm ready. I'm going to go a little faster here. So there's your Y. A is missing. X is -2 minus -3 squared. Let me get that squared in a little better there. And then -2 on the back. Let's figure out what this mess is right in here, and then we'll go for it. So I have A times what exactly? -2 minus -3 is 1. 1 squared is 1. Okay, good. So again, just be careful. This 1 is attached to the A. Don't try to subtract. Add 2 to both sides. I get 1A is 6. So it seems kind of silly, but I'll go ahead and write that there just in case. And so you do see, of course, you would divide by the 1. A is 6. I'm hoping somehow, some way you got that. All right, that's great. So yeah, it looks like an A value of +6. And so let's see. X minus H squared. So rather than doing X minus -3 at this stage, probably should have done that earlier too. but it's x plus 3 squared. And then how about a minus 2? That's it? Good. By the way, you know, we didn't get to talk too much about that a value. We know it affects the direction, but it also affects the width of the parabola. The larger the number, the more narrow it is. The smaller the number, the wider the parabola is. Ooh, all right. One more. Let's put it into action here. So I guess I researched some of the schematics on this particular jet. So let's see. One of the jets at the Bellagio Hotel in Las Vegas shoots a parabolic arc of water 50 feet across the pools. The maximum height of the water is 225 feet. So if you've ever seen this display, it's pretty impressive. There are thousands of things going on with these jets. I just got the schematics, as I said, I think on one of them. So we'll just play it out accordingly. So we could do this a couple different ways. But I do see parabolic arc of water, 50 feet across, and the maximum height is 225 feet. So I'm going to start it out like this, and we're going to try to model this algebraically. You could do this a couple different ways, but I'm going to start my jet right here at the origin. And basically what happens is it shoots a parabolic arc of water coming up and then coming back down right here. Now, I guess the argument can be made, just based on the way I drew that right there, and a very rudimentary drawing at best, that you can tell me 3 different ordered pairs there. We only need 2, but I'll bet you could tell me 3 if I made you. So what would you say? Well, let's go with the obvious one. This one's 0, 0. Kind of starting it out, there's the jet. Which, by the way, does mean, if you look, that's 50 feet across. This one right here, same level, looks to be 50, 0. Right? So it looks like 2 points on the parabola taken care of, and here's the key. What's the third? And you see in the information, the maximum height is 225. That's from here up, and it's right there. And the question, of course, becomes, what is the x value with that height, or that y value being the 225? And here's that great symmetry in parabolas. If it's 50 feet across, it hits that max right there at 25. Okay, fantastic. So I think we're ready to roll. Let's label a couple things. Now it should mirror exactly what we did in example 3, because everyone take a look. I have the vertex. There's your h and k. I have another point on the parabola. Either one works, by the way. I like this one a little better, so I'm going to do that. If you use 0, 0, it works just fine. All right. So write an equation for the arc of water, and then let's do a little predicting from it. Drawing is ready to go. I'm going to work up here because I don't know if I have enough room in this area here, but let's start part B. So everyone, you know it's y equals a x minus h squared plus k. Absolutely outstanding. Now what I see is we have everything but a. The y value is 0. When the x value is either 0 or 50, I'm going to go with the 50. And then h is 25. Don't forget the squared, please. And then plus 225. I've seen students over the years immediately move that over just so it doesn't get in their way. I think that's a good idea. But let's see what we've got going on right here. So I have 0 equals a, and then 50 minus 25 is 25. 25 squared, everyone, I get 625. Again, just be careful. These do not combine. This is attached to the a. Okay, so subtract 225. And I get my 625a right there. And let's go ahead and divide. I'm going to have to bring up my calculator to do this. You guys do the same if you would. But let's make sure that clicks. Okay, so I have, let's see, negative 225 divided by that 25 squared, which was 625. And there we have it. Nice a value, looking good. So negative 0.36. And we knew it had to be negative, right? There's your jet shooting up, coming down. Okay, good. Let's put them in. So now for the infinite number of points on that parabolic arc of water, I have y equals negative 0.36. How does x minus 25 squared sound? And then plus the 225. Okay, wonderful. Now, what do you say we make a couple predictions from this? We just have to be careful. Whatever drawing you use, just make sure your information is consistent all the way through. So when I do my prediction on C and D, it needs to work. So it says find the height of the water 15 feet away from the jet nozzle. So start at the jet nozzle and go 15 feet. And so that would be basically right here. And so I hope you all agree that the x value is 15 here. So just keep that in mind as we go through the process. Now, if you drew your parabola differently with different ordered pairs, and that is totally possible, by the way, you would have a different x value with this. But I'm going to say x is 15. And so the nice thing about this is, given an x, I should let the calculator do the work. We just need to find the y. So 15 minus 25, then it'll be squared, and add the 225. And that's it. Given one, find the other. Okay, let me bring up my calculator and make it happen. So I have negative 0.36. I'll do parentheses, 15 minus the 25, and then I'm going to square it. There it is. And add the 225. Nice. I'm getting about $1.89 on that. Perfect. All right, and I'll go ahead and put that in here just in case. So the y value, 189. Really, really nice. Given an x, find the y. Now, here's the one I really like. How far is the water from the jet nozzle when it is 175 feet high? Okay, so what do we say? This is about 189. So, I don't know, I guess according to my drawing, 175 would be right here in terms of the height. And as I go across, it looks like it would be once on the way up. And, hey guys, look, good algebra here, once on the way down. So two different values I guess we should see. Let's see if we can solve it algebraically. Okay, I'm going to find some room for this. So now everyone, given a y, can you find the x's? So x minus 25 squared plus 225. All right, guys, if I made you solve this one all by yourselves, what would be your first two steps to solve for the variable? I'm hoping you would all agree. You would subtract the 225 over. Then I'm hoping you would agree. You would divide by negative 0.36. Let's do exactly that and see where we are at that point. So I'm going to bring that calculator up, and I'm going to take that 175. I'm going to bring over the 225, everyone. So subtract 225, and I get that. Now I'm going to divide by the negative 0.36. And I've got about 138.89. All right, this is interesting. And here's what I would ask. What do you do now? Well, we've solved equations like this before. Undo the square. So I'm going to try to find some room in there. Undo the square here. Undo the square here. I'm going to have to bring this on over to this other side. When I undo the square on the right, I get x minus 25. Wow, that's great. Now when I undo the square on the left, don't forget, when you undo a square, you have to take both roots. So let's go ahead and do square root of our answer there. And we get about 11.79, but plus or minus. Undo a square, everyone. We get that piece right there. Okay. And then what would you do here, everyone? What would you probably do to pull this off? I'm hoping you would agree you would add 25. So it's 25 plus 11.79, and it's 25 minus 11.79. Let's see if that works. I'm going to do both of them. I hope this kind of makes sense over here. We got the square root of our answer. We got that, plus or minus on it, and that's how we get both answers. And you can see, just again, on my cruddy little drawing there, should be two answers, one on the way up, one on the way down. Well, let's get the one on the way up first. I think that would be the 25 minus 11.79. So that's about 13.21 feet away. And again, that makes sense based on what we got for part B. That was 15 and 189, so this is about 13 and 175 there. So that looks good. And then coming on the way down, how about 25 plus 11.79? And obviously we get that. So, two good answers. We'll wrap it up on this one. So 13.21 feet away, and what did we say on that other one? 36.79 feet. So really, really good high-level algebra there. By the way, what would happen if you added these two numbers together? What do you think you'd get? 50. And that's not a coincidence there. Okay, no reason to go into that in too much detail. I think we've covered enough. So some great mathematics at this point. We're really kicking it into gear here. Get some practice on that algebra working with the completed square form, and let me know if you have any questions on it. Thanks for listening, of course, everyone.